Okay, so this lesson, I'm going to do some things that are a little bit different than the book. I'm going to show you both ways and hopefully tie this together. We'll use tomorrow and go over this some more. But the big thing with this first part is the unit circle. I would just mark the center is 0, 0. The radius is 1. And the equation of the unit circle is x squared plus y squared equals 1. And just draw the unit circle around the origin with radius 1. So when we can actually find points all along the circle, all the way around the circle, by using sine and cosine. If I know what this angle is here, if I take cosine of that angle, it will always tell me the x coordinate. If I take sine of this angle, it will always tell me the y coordinate. So, big idea here, cosine of theta is the x, sine of theta is the y, no matter where it is on the circle. All right? Now, if you think about it, the longest distance here is 1. So all values have to be between 0 and 1 for x and y. And since x is cosine and y is sine, that is also true. And since x is cosine, x squared is cosine squared, y is sine, so y squared is cosine squared. This is one of the main trig identities that you're going to use throughout the rest of the year. So everything that I underlined on this screen, you want to write down. And if you're confused, that's normal at first. Just be patient. Now, when we get into special triangles, we won't always have a unit circle. I'm going to show you some things that I think make it easier, but I'm going to show you what the book does as well. So the three main trig functions, sine, cosine, and tangent, don't worry about drawing this picture. This is what you need to know. Tangent, if I take tangent of this angle here, it's always going to be sine divided by cosine. And since sine is my y and cosine is my x, those are my two main things I want you to know right here. Tangent is sine over cosine. That's another trig identity. That's important. And then to calculate tangent, we're going to just take our y value divided by our x value. The other thing, if you just look at the picture, the slope of this line here is tangent because I'm putting my sine or my y value over my x. So my change in y over my change in x. Tangent will always represent the slope or gradient of that line segment. So I probably would include that as well. Now, this is kind of a nice little exercise. If you are on Snowflake and want to try, see how it works, that's fine. But you can actually calculate this pretty easily. We know that cosine is the x, sine is the y, and tangent is y divided by x. In the first quadrant, x is positive, y is positive. In the second quadrant, x is negative, y is positive. In the third, both x and y are negative. And in the fourth, x is positive and y is negative. So let's think about in quadrant 1, cosine is positive because x is positive. Sine is positive because both x and y are positive. If I take y divided by x, y divided by a positive divided by a positive is still a positive. Now use the second quadrant. X is negative, y is positive. So because x is negative, cosine is negative. Because y is positive, sine is positive. And y divided by x, a positive divided by a negative, tangent is negative. Try the third. X is negative, y is negative. So cosine is negative, sine is negative, but a negative divided by a negative is a positive. Try the fourth. X is positive, y is negative. Cosine positive, sine negative, positive or negative divided by a positive is negative. Okay. So everything is positive in the first. Sine is positive in the second, tangent in the third, cosine in the fourth. There's a little acronym that we use to remember this. All are positive. This is how you remember where things are positive. All students take calc. They're all positive in the first. S, students take calc. S is for sine. T is for tan. And C is for cosine. This helps us remember where functions are positive. The book has another goofy thing, and I don't remember what it is. That's what we do here. All right. Periodicity is basically how often will it repeat? So think back on this thing here. If I have this line, this radius, and it goes around and around and around the circle, if I go all the way around the circle, remember that's 2 pi, if I go all the way around. So if I take the angle and add 2 pi k, that just puts me back in the same spot as I started from. So we say cosine and sine both have a period of 2 pi because it goes all the way around the circle. Why do you think tangent is pi? Because if tangent is sine over cosine, that's this coordinate here. If I go 180 degrees or pi, that's going to put me at negative sine over negative cosine, which the negatives cancel and gives me the same thing. So we say cosine and sine have a period of 2 pi, and tangent has a period of pi. Notice this little k. The k just means it's an integer. You can go around 1 time, 2 times, 3 times, or it could be -1, -2, -3. Okay, so this coordinate point here, if I draw an angle of 157, what's the x coordinate? X is cosine of the angle. Y is sine of the angle. Same for Q. X is cosine. This time I'm doing a negative angle because I'm going backwards of -72. Y is sine of the angle, -72. Now, if you plug this into your calculator, you need to make sure that your mode is on degrees so it calculates the right coordinate point. If you want to go to 3 sig figs, -0.921, and sine of 157, 0.391. Now, does this make sense? That cosine is negative and sine is positive. In the second quadrant, the x is negative and the y is positive. So that should make sense. All right, so then point Q going 3 sig figs. In the fourth quadrant, the X is positive and the Y is negative. So then that's correct. And that's section C. Let's look at section D now. This gets into stuff you're going to use quite a bit and you really need to be pretty solid on. It also is where I differ just a little bit. So think about your 45, 45, 90 triangles. These are your special triangles. In a 45, 45, 90 right triangle, since these two angles are congruent, the sides across from them are congruent. So it's a 1, 1, square root of 2 triangle. In a 30, 60, 90 triangle, across from the 30 is the 1, the hypotenuse is always 2, and 60 is the square root of 3. Now, sometimes this is when these are in degrees. You also need to be just as fluent in radians. So because pi is 180, if we convert 45 into radians, 45 is the same thing as pi over 4. And maybe think of it this way. If I multiply by pi over 180, that's how I can get this. This might help some of you better, but the way I think of it is pi is 180. What do I divide 180 by to get 30? I take 180 divided by 6, and that's 30. What do I take 180 divided by to get 60? 3. So in terms of radians, that's pi over 3. Or if you need to do the conversion to see it better, that's where it comes from. But these 3 are going to be critical for you just to know. So you really need to get to know those well. Okay. So in your notes, I have this on the left side. It's more of a reference, and this is where I'm going to be just a little bit different. So in this triangle, if this is 45 degrees, this is a right angle, and this is 45. This is our 1, 1, square root of 2. Well, if we were to draw a circle, this is our radius. The hypotenuse is always the radius. In the unit circle, the radius has to be 1. And what they do is no matter what this radius is, they divide both the x and the y by the radius, and that's where they get 1 divided by the square root of 2 for the x, 1 divided by the square root of 2 for y, and then they just make you kind of memorize that 45 is this coordinate point. Well, to me, it's way easier just to leave it like this, because you know that a 45, 45, 90 triangle has 1, 1, square root of 2. We know that sine is y. If the radius is not 1, we just divide by the radius. Cosine is the x. If the radius is not 1, we just divide by the radius. This is how we can just convert into this. This can be more confusing. If you just always divide by the radius, you're good to go. Okay? All right, so for this particular one, if we're taking sine of 45 degrees, this is my x value, x, y, and then this is my radius. So sine of 45 is y1 over the radius square root of 2. Cosine of 45 equals the x1 over the radius square root of 2. Do not freak out if this is not sinking in. We will go over this more tomorrow. I'm just kind of getting you the heads up and then start. Okay. All right. So in a 60, Here's my right angle. The right angle is always connected to the x-axis. This is 30, so I go across from 30 is 1. Hypotenuse is always 2, and across from 60 is the square root of 3. In the first quadrant, everything is positive. That's also important to kind of know. All right, so sine of theta, remember, is, oops, I'm already getting ahead of myself, y over the radius. Cosine is x over the radius. So in this angle, the angle you're talking about, is always the angle connected to the origin. So sine of 60, sine is y over r, y square root of 3 over r 2. So if it helps, x, y, r. The more you write this out, it just gets into your head. Cosine of 60 is the x1 over the r square root of 2. Now, I also drew the 31, so let me, I don't know if that would help you. Oops. Let's look and see if this were a 30-degree angle. My angles are never quite, I just draw them all the same. This is always the right. Across from 30 is 1, 2, square root of 3. So notice with 30 and 60, it's really just the x and the y that get traded. So sine of 30 is y 1 over square root of, over 2. Cosine of 30 is x square root of 3 over 2. What would tangent be? Do you remember that we talked about tangent is sine over cosine, or y over x? So tangent of 60 is y over x, square root of 3 over 1. Tangent of 60, y 1 over square root of 3. So these are going to be, what we're going to be doing with these. These are all your first quadrant angles for 30 and 60. Then we're going to move these all around the unit circle. That's what we call the unit circle. Like if you ever get this in college where a professor throws this up at you, this is where we take, like this is a 30-degree angle, and we divide by the radius to get my x and y coordinate. So this is, the x is cosine of 30, and the y is the sine of 30. This is cosine of 60, sine of 60. And what they do is just move it all the way around, and these are all, and then when we start getting past into the second and third quadrants, we start using reference angles. All right, so go ahead and copy the reference angle definition. The key for the reference angle is it's got to be an acute angle formed by the terminal side and the x-axis. Very, very, very important. All right, so I'm starting to run out of time, so I'm gonna hustle through the end here. 330 degrees. If I go all the way around the circle, remember this is 360 all the way around. So 330 puts me right here. See how this is a 30-degree angle? Because that's what's left in between. So it's the acute angle formed by the terminal side and the x-axis. All right, I'll have to finish this later. once you find your reference angle, just list it. It's this angle right here in between. It's that acute angle, and it needs to be positive. Okay. All right, remember when drawing a negative angle, you're going to start at 0 and go backwards. Negative 90, negative 180, right through here. If this is negative 180 and this is negative 225, you just want that acute angle between the terminal side and the x-axis, so you just subtract. Okay. Now the radians, sometimes people get a little bit freaked out about it. This is 0, this is a half pi, this is 1 whole pi. 2/3 of a pi is going to be more than half a pi, but less than 1. So it's going to be right here. Now, if this is 2/3, how much is left here is 1/3, or just pi over 3. So negative, so you really have to decide 5/6. If this is negative 1, this would be negative 1. This is negative a half. Going backwards to negative 1/2 is before negative 1. This is negative 5/6. How much is in here? And remember, it's always positive. It's just that little bit in between is 1 pi over 6. So you're really just completing this right here if this is more than a half. Okay, so then we're going to use those to find exact values. So your first goal is to draw this correctly, 3/4 pi. So that's more than a half, but less than 1. So it's right here. If this is the angle itself, we're going to draw a triangle. What is our reference angle? If this is 3/4, this is 1/4. Now remember, the 1/4 pi over 4 is the same thing as 45 degrees. To me, I think it's easier, once you find your reference angle, is to find what it is in degrees, because now this is our 1, 1, square root of 2 triangle. Now think about our x is going to the left, so it is a negative value. Y is going up, so it's positive. As soon as you draw your reference angle, create triangle always with the x, always with the x-axis. Then we're going to list sine, cosine, and tangent. We're going to use the angle itself. Sine of 3 pi over 4. Remember, sine is y over r. Y over r. Cosine of the angle. Cosine is x over r. X over r. And tangent of the angle is y over x. Y over x, which just simplifies to negative 1. All right, let's look at letter B. So 4/3 is 1 and 1/3. So if we're starting at 0, here's a half, here's a whole. This is really like 1 and 1/2, right? 3 pi over 2 is 3 halves. 1 and 1/3 is more than 1, but less than 1 and 1/2. So it's right here. And then we're going to connect to the x. So if this is 1 pi, how much is this? It's the 1/3. So this is pi over 3 is the reference angle. Pi is 180 divided by 3 That's our 60. So it's our 60, 30, 90, 1, 2, square root of 3. X is going left, so it's negative. Y is going down, so it's negative. Then I just need sine, and I just copy the angle down each time. Make sure you're writing the exact angle. Cosine, tangent. So sine is pi over r, y over r. Cosine is x over r. And tangent is y over x. Okay, so this is asking us to show, this is kind of like a proof. I'm just going to take this in pieces. So first we need to figure out sine of pi over 3. I'm going to draw sine of pi over 3. Remember, pi over 3 is 60. So this is our 60, 30, 90, 1, 2, square root of 3. So sine of pi over 3 is y over r. Then I need to find cosine of 5 pi over 6. 5, 6 is almost 1, but not quite. So this angle here, that's our pi over 6, our leftover, which is 30, 30, 60, 90, 1, 2, square root of 3. But in the second quadrant, our x is negative because it's going left. So then I find cosine of 5 pi over 6, which is my x, over my r. So I'm just going to substitute these two values. And you got to remember multiplying. So put that over 1. Radical 3 times negative radical 3 is just negative 3. Negative 24 over 4 is negative 6. Okay. The juniors are finishing up a test, so that's what you're hearing, but I'm not probably bothering you. Okay, 0 to 2 pi. So 0 just means I'm going to go all the way around. So I want you to think about, where is cosine positive at? All right, so all students take count. Where is cosine positive? In the first, because everything's positive, and also in the fourth. So I'm going to draw a triangle in both my first and fourth quadrants, because that's going from 0 to 2 pi. Cosine is x, 1, 2, square root of 3. And so this creates the two different triangles here. So what angle is across from square root of 3? That's our 60. Now, you have to be careful because our domain is in 2 pi in radians. 60 degrees is pi over 3. We also have this one, which is 300. If you want to convert that into radians, so my two angles are pi over 3, the one in the first,